Large language models, or LLMs, have made impressive strides in handling complex reasoning tasks, but there's still a lot we don't fully understand about how to train these models effectively, especially when it comes to improving their base reasoning capabilities. This research paper, titled DeepDistill, dives into that challenge by focusing on the quality and selection of training data. The authors, from a team including Xiaoyu Tian, Caitong Zhao, and others, point out that while proprietary models like OpenAI's O-series can excel on tough benchmarks, such as solving about 73% of problems on the AIME 2024 math competition, open-source models often lag behind. For context, AIME 2024 is a rigorous math test, and even advanced models like GPT-4o only manage around 13%. The key insight here is that models trained with strategies like extended chain-of-thought reasoning or reinforcement learning, as seen in DeepSeek R1, perform much better. But the academic community needs a deeper understanding of how to build these capabilities from the ground up. To tackle this, the researchers created a massive dataset designed specifically for training LLMs on reasoning tasks. This dataset includes about 3.34 million unique queries, each graded by difficulty, and paired with around 40 million distilled responses. These responses were generated through a multi-pass process using various models of different strengths, which helps avoid the biases that come from relying on just one model to judge what's hard or easy. Let me explain how they built this. Traditionally, assessing problem difficulty might involve a single model scoring or evaluating examples, but that's problematic because it's subjective and can depend on the model itself or how you prompt it. For instance, what one model finds difficult might be straightforward for another, leading to training data that's not truly representative. To fix this, the team used a multi-pass distillation approach. They had multiple models attempt to solve the same queries multiple times, generating a wide range of responses. Then, they analyzed these responses using two main metrics: the pass rate and the coefficient of variation, or CV. The pass rate is basically the percentage of times a query was successfully solved across all attempts, giving a clear measure of how challenging a problem is on average. The CV, which measures the variability in those success rates, helps identify queries that are consistently tricky or unpredictable. By combining these, they could precisely select the most valuable data for training, focusing on examples that would push the model to improve without overwhelming it. This data selection process is a big part of their innovation. They emphasize that not all reasoning problems are equally useful for learning. For example, mathematical puzzles, code generation, or logical challenges vary in form and difficulty, so tailoring the training data to the model's needs is crucial. With this carefully curated dataset, they trained a base model using supervised fine-tuning, or SFT, which is a method where the model learns directly from high-quality examples. During training, they noticed an interesting pattern. When focusing on reasoning tasks, base models often require higher learning rates to make effective progress. This means adjusting the training parameters to allow the model to adapt more quickly to complex patterns, which isn't always the case in standard LLM training. The results were impressive. Using their selected data, they boosted the base model's reasoning capabilities significantly. On the AIME 2024 benchmark, the model achieved a pass rate of 79.2%. Which outperforms most current distilled models and gets very close to state-of-the-art performance. To put that in perspective, Figure 1 in the paper shows how various open-source models stack up on this benchmark, highlighting the gap that their approach helps close. The paper also details their full methodology, including how they processed the data, assessed difficulty, and handled the training. For instance, they describe generating the responses through multiple passes, ensuring diversity in the solutions, and then filtering based on the metrics I mentioned. This graded design makes the dataset versatile. It can be used for models of different sizes and even for other applications like downstream alignment techniques, such as DPO or GRPO, which are methods for fine-tuning models to align with human preferences. Finally, the authors have made everything publicly available to encourage progress in open-source LLMs. You can access the dataset at the Hugging Face link. https://huggingface.co/datasets/a-m-team/m-deepseek-distilled-40m. This openness is crucial for the community, as it allows researchers and developers to build on their work and accelerate improvements in long-form reasoning. Overall, DeepDistill demonstrates that with thoughtful data curation and training strategies, we can substantially enhance how LLMs handle reasoning, paving the way for more capable and reliable models in the future.